Okay, we're going over the open book test for 2.122 of calculus, and what we've done is introduced the idea of a derivative. Now, the derivative of a function gives us the equation for the slope of the tangent line at any given point. We learned how to find the derivative using the difference quotient in Unit 2.1, and then we streamlined how to find derivatives in Unit 2.2, and we'll learn more rules about finding derivatives in 2.3 and on. So we're going to begin going over these problems with number 3 because that's the 2.1 part, and then the rest of the worksheet is 2.2. So we're going to begin with number 3. We want to find the derivative using the limit process. And when we think about that, we really want to go back into our mind and we want to think about where all of this investigation began. We said if we have some type of a curve, and this is not the curve represented by this function here, but we said if we had a curve and we had a point on that curve, we could call that point x and f of x. Then if we wanted to find the tangent to that line at that curve, one way to do that would be to, if we wanted to find the slope of the tangent line at that point, then one way to estimate it would be to pick a point out here and then find the slope of that secant line, and that would be an estimate. Or if we moved that closer, that would be a closer estimate. Or if we moved that closer, that would be a closer estimate. And so we're talking about some second point C, and as C approaches x, then the change in x would be approaching 0. Okay? And this other point up here would be f of C. And we know that to find the slope of a line, way back from beginning in Algebra 1, that slope is equal to change in y over change in x, which could be found with the difference quotient, y minus y sub 1 over slope, which is x minus x sub 1. Now, so the way we're going to use the difference quotient is with the y minus y sub 1 over x minus x sub 1, except we're going to realize that we're really looking at change in x approaching 0, and we can identify the x minus x sub 1 as change in x, and that gives us a division by 0 error, which means that we need some calculation to remove that discontinuity of 0 so that we can actually get a calculation at that point. Okay? So the difference quotient looks like this. It says the limit as delta x approaches 0 of. Now, if I picked a second point that was like C, another way to write C would be to add the distance here to that. So another way to express that point C is x plus delta x. And its function value up here would be f of x plus delta x. So if I take the difference in the y's, f of x plus delta x minus f of x over the difference in the x's, which we really could just write as change in x, then we have the difference quotient. So as the change in x is approaching 0, in other words, as this second point approaches actually being the point itself, then what we have then is the tangent line itself, or we can have the slope of the tangent line at that point of tangent C. Okay? So here's our difference quotient, and then we're just going to plug into that. So here we begin to work. We want to find the derivative of the function negative 5x. So we're going to have the limit as delta x approaches 0 of. Now, we want to find f of this. That means in the f function, we replace the x with that. So that's going to look like negative 5 times. Insert x plus delta x where the x was in this f function. And then the minus sign. And then now we're going to replace the x in the f function with x. And so we would have minus 5 times, replace x with x, and we still have an x over delta x. Now, we're going to distribute here. So we have the limit as delta x approaches 0 of negative 5x minus 5 delta x. And then minus a negative is a plus 5x over delta x. Now, it's going to happen that each time you use the difference quotient, any term in the numerator that does not have a delta x will have a partner in the numerator that's its additive inverse, and then they will cancel out, so that the only thing you're going to be left with is delta x terms in the numerator. Now, if it was more complicated than this, then you could factor out that delta x term and then have a cancellation opportunity. Here, we have negative 5 delta x over delta x. We see the cancellation opportunity here. So we have that the limit as delta x approaches 0 of f of x is negative 5. And so we've calculated the derivative. Now what that tells us is that the equation for the slope of the tangent line at any given point is, we would say, f prime of x. The equation for the slope is 5, negative 5. That means the slope is always negative 5. And you may say, well, that's a little bit weird, especially considering the graph that we had up here that was a curve, but that's not really the graph of this function. So let's consider the graph of this particular function so that can make sense to us. This function was actually, again, negative 5x, which is understood to be plus 0 out there. So the graph would begin at 0, and then you would go down 1, 2, 3, 4, 5 to the right 1, and have a point. And we would have a line that looks like that. Now, this is not a curve, it's a line. So if I pick any point on that line, the tangent is the line itself. If I pick a point on that line, the tangent is the line itself. So the slope of all the tangents at every single point is the same as the line itself, and the slope of the line itself is negative 5. Okay, any questions on number 3? All right. Now, it might be good for us to do one more example here. I'll just make one up so that we can have something that's a little more complicated to solve. So I'm just going to change this up, and we're going to make an example 3a, and we're going to say g of x. I'll just call it g of x. I'm going to call it f of x. So we'll call it f of x is equal to 3x squared minus 2x plus 1. We'll just give us a good long one. So we're going to use the limit process to find the derivative on 3a, okay? I'll just go ahead and write out the 3 here so it won't be bothering us. Okay, so we're going to have the limit as delta x approaches 0 of, we want to find the f of x plus delta x. So where the x is, we would replace it with x plus delta x. So we're going to have 3 times, replace the x with x plus delta x, minus 2 times, replace the x with x plus delta x plus 1, and then minus f of x minus f of x, replace the x with x, and you have what you started with, over delta x. So we found f of delta of x plus delta x minus f of x. So we replace the x in the f function with x plus delta x, and then we replace the x in the f function with x. And now we're going to go through the simplification process. We're going to distribute. Over here we need to distribute that negative. And so we're going to have the limit as delta x approaches 0 of 3x plus 3 delta x minus 2x minus 2 delta x. And then we have a plus 1 there. And then we have some sign changes, negative 3x squared and plus 2x and minus 1 all over delta x. Now, again, everything that does not have a delta x attached should have a partner term that will cancel. I'm not seeing a cancellation for 3x, and so I'm looking for a mistake, so you know why I paused. See, I forgot to put my square right there. Wow. Let's go back. Sorry about that. All right, left my square on. Here we go. The limit as delta x approaches 0 of, where the x is in the f function, we're going to replace it with x plus delta x. So we're going to have 3 times x plus delta x squared, I left my square on, minus 2 times x plus delta x plus 1, minus f of x. That means we replace x with x, and so then we would have 3x squared minus 2x plus 1 all over delta x. There we go. So we need to square the binomial first. So we're going to have the limit as delta x approaches 0. When we square the binomial, we'll have the first item squared plus 2 times the product of those, 2x delta x, plus the second item, delta x squared. And again, that's in parentheses with the 3 multiplied. So all we did was square that exponent. I'm just going to put everything else back right now. Minus 2, open, x plus delta x, close, plus 1, minus, open, 3x squared minus 2x plus 1 all over delta x. So we did the exponent, and now we're going to distribute. And so we're going to have the limit as delta x approaches 0 of 3x squared plus 6x delta x plus 3 delta x squared minus 2x minus 2 delta x plus 1 minus 3x squared plus 2x minus 1 over delta x. Now, because I've now squared my binomial, it should be that any term that we find in the numerator that does not have a delta x should have a partner, an additive inverse partner that will cancel it. So we have a 3x squared here. We know then there would be one over here that would cancel. The next term had a delta x. The next term had a delta x. The next term had only an x. And so there should be, with that minus 2x and plus 2x, it cancels. This term had a delta x. So we got a plus 1 without it. There should be a minus 1 that cancels it. So we're left only with terms that have a delta x in the numerator. So then we have the limit as delta x approaches 0 of 6x delta x plus 3 delta x squared minus 2 delta x all over delta x. Now, because these terms that remain each have a delta x factor, then I could factor out that delta x factor. So when I factor out a delta x, I would have delta x times 6x plus 3 delta x minus 2 all over delta x. Now, what we really wanted to happen is we really wanted to remove the delta x from the denominator because delta x is approaching 0 and division by 0 is undefined. You may notice that when those cancel, there's still a delta x in the numerator, but that's not a problem because it's okay for there to be a 0 there. It's just going to wipe that delta x out when we replace it with 0. So once we get to there, if we had replaced that division, that divided by delta x with 0, we would have had a division error, but that discontinuity was removed. So now, with what is left, we have the limit as delta x approaches 0 of 6x plus 3 delta x minus 2. And by taking the 0 now and putting it in the delta x place, that particular term cancels out. And so we have the limit as delta x, we have the limit as delta x, one more time. We have the limit as delta x approaches 0. I'm going to write it at the top. I'm messing up, and it's not being very forgiving either. I'm just going to put it right here. So we have the limit as delta x approaches 0 of f prime of x is equal to 6x minus 2. And what that is that is the equation for the slope of the tangent line at any given point. It's the equation for the slope of the tangent line at any given point. So we found the derivative of the original function using the limit process. So if we knew a point on that function, we could plug the x of that point in the x position in our equation and find the slope at that given point. Okay. Any questions on that? All right, thank you.